Calculate the mass of silver. Calculate the mass of silver deposited when 0.2 ampere. Calculate the mass of silver deposited when 0.2 ampere of electricity. Calculate the mass of silver deposited when 0.2 ampere of electricity is passed. Through a silver chloride. Through a silver chloride solution for 2 hours. Given that the chemical equivalent given that chemical equivalent of silver is 0.00098, 0.00098 gram per coulomb. 0.00098 gram per coulomb. 0.00098 gram per coulomb. From first law of electricity yesterday, we said mass is direct proportional to what quantity of electricity. Mass equivalent. Z is what? Chemical equivalent. So therefore, M equals to Z, and Q is what? ZIT. And that chemical equivalent. Now, what's the units? That's what I'm going to. You can make this Z the sort of a formula that divided by what? Q, M over Q, right? In chemistry, we use gram for our mass, right? Q, what unit of Q? Coulomb. That's what? Gram per coulomb. Or can make it like this, gram per coulomb. What's on the question?
Calculate the mass of silver deposited.
Now, you can either use this formula or you can use this formula based on the parameters they gave you. Mass of silver deposited. All right, mass of silver, MAG, is unknown. That's what I was asked to calculate.
When 0.2 ampere of electricity.
When 0.2 ampere, 0.2 ampere of electricity is passed.
Through a silver chloride.
Look at that girl. Through a silver chloride solution. Silver chloride solution. Now, silver chloride. What's the time? 2 hours. I told you yesterday that your time must be in seconds in the previous class. Therefore, you have to convert these hours to seconds. What is the conversion? 3,600 seconds equals what? Who is that? I don't stop it. Listen, you are distracting them. What's the opinion with that? I've decided the question. 300 seconds equals to what? If you now, I could remember what's the business? Imagine my man load it. Stop it. 300 seconds equals to what? 1 hour. So therefore, these hours, you are going to write 2 hours here. Put x here, cross multiply x times 1. That's x times 1 is x. 300 times 2. 7,200 seconds. I'm not waiting now. So this is your time. I can put t here instead of x. So if you put x also, it's the same thing, no problem. You have your time, you have your current, and you gave you chemical equivalence. Chemical equivalence Z. What's the value?
0.00098.
Gram per coulomb. You have this T time and your current. Which one are you going to use? Is it this or this?
M equals
We are going to use this, right? M equals to ZIT. M equals to ZIT. Your M is your mass. Z is what? 98 times I. What's the I? What's the T? Times 7,200. Do the multiplication. What's the final answer? 0.14 gram. Don't sit down this place. Sit down at that place there. Move forward to that place. And take your bench to that side there. You said it was, you changed it from CRS to economics. You go and do the correction of data, right? Okay. You have not registered. Now, example 2. Calculate the mass of copper. Are you done writing? Read your books. I don't want all these side talks. Bring out your government. You can read your book. After they are done writing, clean the board. You shall do it ready. Yeah, I don't have side talk. Yes. Are you ready? Be fast. Why are you talking? Was you telling something? You just said what I'm writing. You don't see what you are writing. You can't see. You don't see the first calculation. I'm not. Hey, that's it on the board now. Or which one is it? Did I clean anything? You can't see. You can't see. Come to the front. Stand up. I just stand up. Who is sitting out here? Give me this bench. Wait. Hey. Law of electrolysis. Write from your colleague, please. Write from your colleague. It's okay, clean the board. Write from your colleague. Fatia, give them your book. Law of electrolysis says that the second law. What is the second law about? 1 mole of monovalent equals what? 96,500 coulombs of monovalent elements. 1 mole of what? Equals to what? When they say monovalent element, what is the example of monovalent element? Sodium ion, potassium ion. So which means 1 mole of what? Sodium ion, potassium ion, lithium ion is equal to what? 96,500 coulomb. Okay, another one. 1 mole of divalent element. What is it divalent? When the valency is true, right? Now, what are example of divalent elements? Calcium ion, copper 2 ion, magnesium what ion? Musa, calcium ion, copper 2 ion, magnesium ion. They are divalent what elements, right? 1 mole of divalent elements equals to 96,500 times 2. That's column, which is 1 multiplied times 2 because it's having positive charge here. Positive charge here. Positive charge 2 positive charge, right? That's 193,000 column, right? What of 1 mole of trivalent elements? 1 mole of what? That where valency is 3, right? Trivalent. Example of trivalent. Aluminium. That's 196,500 times 3. What's not the value now?
289,500.
Column, right? What is that measure copper 2 times over 6 solution? Copper 2 times over 6 solution. Copper 2 times over 6 solution. That's Cu2 plus SO4 2 minus. This and this can cancel each other, right? That's CuSO4. That's what copper. What is it, copper or copper 2 days? Copper 2, right? So now waste means 1 mole of what? Copper 2 ion equals what? 96,500 coulomb times 2 is a constant value, just like 10 millimeter equals to 1 centimeter. Are you getting now? So now is a constant value. So which means 1 mole of what? Copper 2 ion equals to what? 193,000 coulomb, right?
Yes.
Calculate the mass of copper form. So you are going to use this. You are going to need this. And 1 mole is also equivalent to atomic mass. You are running. 1 mole of element also the same as atomic mass. 1 mole of sodium also equals to 20 grams. 1 mole of calcium is also equals to 40 grams atomic mass. Mole and atomic mass, you can make them equal. Mole and what? So wherever I see 1 mole, I can also put atomic mass. 1 mole of copper is also equals to atomic mass of copper. What is atomic mass of copper? 64. Atomic mass of copper is what?
64.
So which means wherever I see 1 mole, I can put atomic mass there. So I can say 64 grams of what? Of copper is equals to what? 198,000 coulomb. This is your basic conversion. Am I calculating now? So therefore, what are the questions? I'm looking for the mass that they use. I'm looking for the mass of copper that was formed. I mean, when they use this quantity of electricity, if they didn't use up to this quantity of electricity, what is the equivalent? What is the mass of copper that will be liberated? What will be the mass of copper that will be liberated? Look at the quantity of electricity they use in the experiment. 95 coulomb. It's not up to what? 198,000 coulomb. I get you now. So I will now place 965 coulomb here. 965 coulomb. What's the equivalent mass? What will be the mass of copper that will be liberated? Normally, if you use this quantity of electricity, it should liberate 64 grams of copper. I say now this is even your basic conversion. This quantity of electricity will liberate 1 mole of copper in you, and 1 mole also can be equated to what? Atomic mass. So 1 mole of aluminium is equal to what? 27 grams of aluminium also. What's the atomic mass of aluminium? 27 grams, right? Not atomic number, atomic mass. Isn't it? So I can now cross multiply. It's just like we are doing conversion. I can now say 64 times 965. That's 64. Times what? 965 equals to what? M times 193. M times 193,000. So divide yourself by what? 193,000. 193,000. This and this you cancel each other, right? M multiply this, divide by 193,000. What's the answer? Eh? 32. 32 only, right? 0.32 gram. 0.32 gram. You got right. Right. If you have any question, let me know. And you focus there very well. This is atomic mass of copper. What is atomic mass of fluorine? What's atomic mass of fluorine? 35.5. Atomic mass of fluorine 35.5. What's atomic mass of sodium? 20 what? 23. Atomic mass, if I see 1 mole, you can also put atomic mass here. So 1 mole of copper is also equal to, so you can represent each other. Because of I can 1 mole equal to this. I can use this to represent 1 mole. So mass of copper that will be liberated. If you use this constant of electricity, you didn't use up to this. I don't know the mass. I will also equate it. I can now cross multiply this and this, this and this. If you have any question, ask me. Next question, example 3. Are you ready? Calculate. Okay, pause the video. Iguan, are you done writing? Pause the video. By the electrolysis of what? Silver 1295 solution. Full stop. Open bracket now. Open your bracket. Silver equals to 108. Faraday's constant. Sometimes that will not give Faraday constant too. Faraday's constant 96,500 coulomb. Now, where is that my daughter? Where is that daughter? Where is my daughter? Daughter. Now, look up. What's the question? You are looking for Q this time around. The previous example, they gave us quantity of electricity they use in their experiments. They use 965 coulomb. So we are now looking for mass. So if you are looking for mass, you are going to equate atomic mass. Make atomic mass equals to what? 96,500 coulomb. But if that atom, if that ion is monovalent, but it's divalent, that's valency of 2, you multiply it times what? 2. If it's trivalent, you multiply it times what? So because they ask for mass, I will equate atomic mass with this value. So and I will put what 95 column. Quantity of electricity they use here. That's my Q. I'll put it here. Looking for mass. But in this question now, what they ask for is what? They ask for what? Quantity of electricity. They gave you mass. If I'm not mistaken, they gave us 10 mass of silver. Mass of silver. They gave us what? 10.8 gram. And I'm looking for what? The quantity of electricity needed to liberate this mass. What's the instruction? Mass, atomic mass are what? The quantity of electricity, right? We have a case of mole also. We are coming to that. That I will not say, what is the atomic mass of silver? 1 gram equals what? Silver, you ask yourself, is it monovalent or divalent or trivalent? Amachi. Next, I have another column. Where is the mass of silver used? 10.8, right? Gram. Where is the quantity of electricity that's equivalent to? You don't know. You cross multiply. 1.8 times Q equals what? 10.8 times what? 96,500. Divide those by what? 108. 108. Multiply divide by 108. What is the answer? 9650 colon. That's the answer. 9,650 column. Column be unit of what? Quantity of electricity inside. Because if you have issue, let me know. Do you have issue? Example 4 now. I saw you now. Who is there with you? Who is there with you? Come, you don't share no. So you deliverance. When you deliverance, you don't joke to the conclusion by lecture. Have you paused it? It just not be too large. The pause. Some of the 2 lines, stroke line. For how long must a current? For how long must a current of 0.5 ampere? For how long must a current of 0.5 ampere be passed through a solution? Be passed through a solution of silver 2095. Of silver 2095. Of silver 2095 solution. To deposit 0.01 mole of silver. To deposit 0.01 mole of silver. To deposit 0.01 mole of silver. Silver 2095. Solution to deposit 0.01 mole of silver. Now, look up. Since morning, they have not given us mole. Now they gave me mole. It's now time not to use atomic mass and quantity of electricity now. You know, use atomic mass and 19,500 coulomb, right? For monovalent, divalent will multiply times 2. Trivalent multiply times 3. But now they give us mole. We are now going to be using mole and what? Quantity of that. 1 mole of monovalent. I keep writing this thing every time because you need it. Equals what? 9,500 coulomb. But the measure silver is monovalent or divalent. You think of metal and monovalent, right? This is what that 1 mole of silver ion is what 96,500 watt color. What they give you? This is your basic conversion, right? This one come from you, right? What's the question? How long? What way of how long? No time. Time. You are looking for time. It's unknown. Must the current of they give you current. Current. Must the current of what? 0.5 watt ampere. You know these two things. You can use to get current of electricity that was passed through it. And current of electricity is always placed under this value, right? For how long must the current of what? 0.5 ampere be passed through a solution, anything now, of silver 295 to deposit what? 0.1. To deposit 0.01 mole of what? Silver. Now to deposit. This one, what our aim is to deposit 0.01 mole of what? Of silver. I get him now. So look up. This is the mold they gave you, right? You can place it here. Of silver was deposited. I get him now. So what is the quantity of electricity that can be used to deposit it? Once I know that quantity of electricity, I'll put the value here. I get him now. I know my eye. I can get that thing. I get him now. Hope you are here. Let me just get my cube that will be needed to deposit this value of mole 0.01 mole, and we could do to deposit 0.01 mole. 1 mole. This quantity of electricity depositing 1 mole of silver. One quantity of electricity that will deposit 0.01 mole. I will use mole and mole now. So that mole under mole, this quantity of electricity, other quantity of electricity here. Because multiply now. That's 0.01 times 96,500 equals to Q times 1. What's not this now? Coulomb equals to Q. So Q equals to 965 coulombs. Q is what? 965 coulomb. I will now put it here to get my T. I get it now. Q is what? 965. I is what? 0.5 times T. That was by 0.5. 0.5 time 95 by 0.5. 190 seconds. 190. Guys, in the logic now. Pause the video. Timlade, thank you. Are you done? Are you done writing? You are done writing, right? Please. Calculate the amount of current. Yeah, you are looking for current. And amount of current. Amount of current ahead. Tell me this time, right? T equals to 30 minutes. What are you going to do? Convert it to what? How? 60 seconds equals to 1 minute. Don't forget, 3,600 seconds is what? 1 hour. So you put 10 minutes under minutes. You are looking for time in seconds, you don't know. Put 30 here. I get it now. You cross multiply it. That's 60 times 30. That's what? That for everything jam. From seconds from minute to second, the value will be big, right? Just what makes value to be big in my calculation? Multiplication. Just multiply times 60 direct. Don't need to waste time. What of your there's no time. That's what 180 seconds. 180 seconds. 1,800 seconds. I get you now. What the question? The major copper is 6. That's what CU SO for copper 2. What is the charge of copper? That's where they will mention that solution. I get you now. So I know what you are working with. They gave you mass, not more in this time around. Mass of copper 0.8 watt gram. So atomic mass will work with that via this constant, right? And that value constant you multiply times 2, right? Because your copper is what? Divalent, right? What again? Let's go there.
CU is equal to 64.
Oh yeah, so therefore C is 64. That look across Musa 64 equals to 96,500 times what? 2. Musa, do you know why I'm multiplying times 2? Because this copper is what? Divalent. You multiply it now. What is the mass of copper they gave you again? Quantum electricity that will liberate this mass, right? But what question exactly? You are looking for your eye, right? You cannot get your eye here. Although you can get your eye from this Q equals what? IT. I get you now. Although they can also get your eye direct. Instead of removing your Q separately, you can go and put IT here. But look, let's take step by step. Oh yeah, this is now what? 64 times Q equals what? Times 2. Multiply it. Multiply this. Colon, right? And don't forget, Q equals to what? IT. This is your point of electricity. You can put it here. That's what? AFI. You can don't get your eye now. That's this 2. Put it here. That's 2 for 1, 2.5. I is what? Your time is what? Divided by what? Ampere. But another way, you don't want to waste time. If anything jam, just say 64 equals to 96,000. You should not have noted 96,500 times 2. It's only 193. You only 193,000. Hold on. You now put the mass they give you, put it there. 0.8 gram equals to IT. Equals to what? IT. And IT is what? Your Q. Your I is what you are looking for, right? And your T is what? 1,800. So this T here, change to what? 1,800 seconds. I get him now. So cross multiply. 64 times I times 1,800 equals what? 0.8 times what? Multiply this. So you get 0.8 and 190,000. You divide L 0.8 and 115. 154. When you multiply this, right? What like we divide by 64 times 1,800, right? What not the answer? What not the value? What not final? 1.34 ampere. We must still get 1.34 ampere like this. Any of the tools. Oh yeah, right. I look back in the room. Why do you take this thing away from that one? Yes. Is that bad?
You did like this.
Right. Equivalent to atomic mass always equals to Q, right? Quantum electricity, right? Because this constant. But they didn't give atomic mass. Let me take the question. You should try it. 5.0 gram of silver. Right. 5.0 gram of silver was deposited when 0.5 ampere of electricity flows through a silver trough 95 for 2 hours 30 minutes. Or should I show it? For 2 hours 30 minutes. Full stop. Calculate the relative atomic mass of silver. Calculate the relative atomic mass of silver. Calculate the relative atomic mass of silver, right? Full stop. Open brackets. Of Ag equals to 108. Faraday's constant. That's what 96,500 coulomb. Oh yeah, what's the question? Let me solve it. After play, we'll do a lot of correction. A lot of now. I'm still in class. Now look at what's the question. What's the question?
55.04 grams of silver.
Mass of silver. 5.04 gram. Was deposited when 0.5 ampere. That's the current. Flow through a silver 295. Silver 295 is Ag. NO3. For 2 hours 30 minutes. Your time. 2 hours, Mr. Ojo. 30 minutes. What are you going to do? Convert these hours to seconds. Convert these minutes to seconds. Add it together. Now we convert these hours to seconds. 3,000 seconds equals to 1 hour, right? Now we are going from hour to seconds. The value will be big, right? What the value will be big? Multiplication, right? You multiply times 3,000 seconds. These 2 hours. Hope you are here. Hope you understand what I'm saying. Now, so your time here, 2 hours times 3,000 seconds. You also convert this one to seconds separately also. Hope you are here. Do you understand this? What I did here? Daniel, 3,000 seconds equals to 1 hour. Now 2 hours. You have your time in 2 hours. 2 hours. So what do you do at the end of the day? Equals multiply by 3. Now when you go to seconds from hour, the value will be big. In your answer, for answer will be big. So that's why you have to go multiply times 3,000 seconds. Now that's now t equals to 2 times 3,100. Oh yeah, now this is now what now? 7,200 seconds, right? Now this 7,200 seconds. But what about this 30 minutes? You have to convert also. 6 seconds make 1 minute, right? So from minute to seconds, the value will be big, right? What are you going to do? Multiply times what? 60, right? Multiply times what? 60. Now I'll see say 30 times 60. That's what? I'll now add the total seconds together. Add the total time together. 9,000 seconds. I have my current. I have my time. I can get my Q. Right? That was used. The quantity of electricity that was passed through to liberate this mass. This is my experiment values. I let you now. But normal constant value is what? Atomic mass. Equals to what? 96,500 coulomb for monovalent. But silver there is, right? Monovalent, right? Now and I'm looking for atomic mass now. Related atomic mass. RAM. See the same thing. Related atomic mass. I get you now. I have this is a constant normally. So go and get the quantity of electricity that was used. That's Q equals to IT. Q is now I is what? T is what? Oh yeah, Q. Coulomb, right? Now this may be what? 4,500 coulomb. What of this mass here that was like that? This was like what mass? 5.04, right? Gram. What are you going to do now? Cross multiply, right? Cross multiply. I'm looking for RAM, relating atomic mass. Related atomic mass is always as atomic mass. Am I calculating now?
Yes, sir.
My related atomic mass times 4,500 equals what? 5.04 times 96,500. What are you going to do now at the country? That's my words. 4,500. Where's Sheriff? Eh? 100 point what? 0.08 gram. Roughly 108 gram. Right? Eh? I get me now? I get me now? So that's the rate atomic mass of the silver. So 108. I get him now? They are not giving constant value because they are used to giving constant value. So next, after break, after your English class, we are going to do some classwork and have assignment for you. I'm still have other questions to solve though. I get you now. We are going to do electrolysis in chemistry. Your assignment in first question, and I still have other calculation assignment for you. And I'll give you some class